Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First, let me introduce myself. My name is Afshih Lisaan Auliya from Department of Basic Education, Indonesia University of Education. Before I go to my presentation, I would like to thank to Msceis 2021 commit who has given me a chance to present my paper. And the title of my paper is Prediction of Landslide Runoff Distance and Velocity at Sedamukti Landslide using Slope Stability and Center of Mass Approach. Now, landslides are one of the most common geohazards in Indonesia, which cause severe damage each year. So now we will go to introduction. A landslide is caused by a disturbance in the stability of the soil slope due to the increase in water pressure and ground shaking. Landslide involve rotational and transitional sliding, flowing, toppling, or falling movements, and many landslides exhibit a combination of different types of movements. Landslides commonly occur during heavy rainfall periods. Rainwater will infiltrate slowly into the soil, causing the reduction of metric suction to zero, leading to the generation of transient positive water pressure and groundwater development from the slope surface. Landslides are one of the most common geohazards in Indonesia, which cause a significant risk every year. Of the landslide occurrences recorded between 2000 and 2020, more than 90% occur on Java Island. Hilly areas in Java province too are prone to landslide hazard due to geological and topographical factors. And the objective of the study are 1. To determine the geometry of the slip surface, 2. To estimate the runoff distance and velocity, and the last, third, to classify the landslide according to the velocity. And the study area is classified as the medium to high landslide susceptibility zone. Now, the research area in Sedamukti, Pangalengan. This area is the highest in Bandung, is the highest rainfall in Bandung Regency. Based on rainfall data conducted by BMKG in Pangalengan, referring to rainfall data in Bandung Regency, the average annual rainfall is 1,718 until 2,603 millimeter of years. The geological setting of the study area is composed of old and degraded volcanic loose sedimentary rocks in the form of vine. During the rainfall, rainwater will infiltrate slowly into the soil, causing the reduction of metric suction to zero, leading to the generation of transient positive water pressure and groundwater development from the slope surface. Now we will move to method. To achieve the objective of this study, the slope stability analysis were performed to determine the critical slip surface when the safety factor is 1, using slopeway and BIMSTAB software. And the Morgenstern price method was used to calculate the safety factor into slope cross-section with soil certification obtained from resistivity image as shown in figure 4. And factor of safety is needed to determine stability of slope by the balance of shear stress and shear strength and comparison between the force the resist it moved to the soil. And the risk analyzing is a use of available information for hazard identification and runoff distance analysis. And the soil parameter used in the study are shown in figure 5, are unit weight, cohesion, friction angle. To find the slope stability analysis, the runoff distance was estimated using a simple geometric rule based on a simple column frictional model as shown in figure 6, and the velocity of landslide use or based on the energy line concept. Result and discussion. The result of slope stability analysis of two slope cross-section based on slope Y, as shown in figure 8, and based on beam stub and shown in figure 9. It can be seen in figure 8 that the landslide involved the first soil layer with a circular slip surface at a critical factor safety of 1, the green color. In contrast, the slip surface of the beam stub are non-circular of different geometry. It is also seen in both figures that the critical slip surface was developed within the first soil layer under a high groundwater table within the slope. Thus, the groundwater table is the factor controlling the stability of the slopes in the study area. The geometry of the model used to perform the center of mass analysis to estimate the runoff distance and the velocity is used by a simple friction model. The calculation results are summarized in table indicating that the runoff distance and landslide velocity obtained from both software based on slopeware and beam stub are generally in good agreement, except for the result of velocity and model 2. The runout distance and velocity using beam stub are slightly higher than that of slopeware. Because the fall of height of the beam stub model is slightly higher than that of software. Based on the estimate velocity, the landslide in the study area can be classified as an extremely rapid landslide. The landslide may turn into debris flow involving a thick soil layer. Thus, the result of the landslide hazard analysis suggests the effective mitigation to reduce the hazard by controlling the groundwater table in the hill slope. And finally, conclusion. The result of slope stability analysis show that the estimate potential landslide masses obtained from beam stub software show a good agreement with those obtained by geostudio software or slopeware. Based on the estimate velocity of both models, the landslide in the study area can be classified as an extremely rapid landslide with a velocity of more than 5 meters per second and runout distance of approximately 60 meters. The result by velocity more than 5 meters per second was categorized as extremely rapid landslide. Soil type movement are debris flows, rock falls, and complex movement, which rapidly move large volumes of heterogeneous soil type. This condition is damage for structural and functional of infrastructure. This situation is damage for loss of life, injuries, and indirect to population in each research area. So that's all my presentation, and thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.